Dear students, welcome to KCNIT official YouTube channel. Today we will discuss about the what are the data structure operations and algorithm, its characteristics and efficiency of an algorithm, and what are the parameters to analyze an algorithm. So first we discuss about the data structure operations. Here basically there are four basic data structure operations, in which first one is the traversing, means accessing each record exactly once. Means we can analyze in data structure each and every element of data exactly one time. And the second operation is the searching. Searching means find an element in the data structure or in the list. Here for finding any element we can given some keys or key values. By according to this we can search an element in the data list. ठीक है, according to the key or key values, given key values, we can find the record by the searching operation. Next one is the insertion, means add an element in the list. We can add any element in the data structure. The process is called as the insertion. Next one is the deletion, means remove an element from the list. Means we can remove or delete an element from the data structures and in the from the list. And here we can the operation is called as the deletion operation. Basically there are two more data structure operations that we are using in data structures. First one is the sorting. Here in sorting process we can arrange the data in some given logical order. Means if we are using number data, then it will be sorting according to their numeric values, or if character data, then it will be analyzed or sorting by the alphabetically. Next process is the merging. In merging process we combine two sorted sublist and perform it into a single linked list. Combine the two sorted sublist into a single sorted list, and this process is called as the merging process. Now we know about the what is the algorithm. If we can define an algorithm, basically an algorithm is a finite set of instructions that takes some raw data as input and transform it into a refined data. Here basically three words: finite, input and refined data. That is also called as the output. In each and every algorithm, the number of steps should be finite. We take some input and transform it by applying some process into the refined data, or you can say it will be in the form of output. We can also define algorithm as a well-defined finite steps to solve any computational problem. Like if we have any computational problem, then we can define it by the number of process to solve how it can be solved by the algorithm. Now we discuss about the what are the characteristics of an algorithm have. And the first one is the input. In input basically there must be at least 0 or more data input. Means there must be 0 or more data as input. Here we are using 0 data. Basically in that case when the algorithm can only check the condition. Second is output. Here at least one output is produced. Means algorithm can produce at least one output definitely. Third one is the definiteness. Definiteness, each instructions must be clear, and unambiguous. Means instruction must be clearly defined and they are unambiguous. Means there is instructions have no double meaning. Next one is the finiteness. For all cases, algorithm will terminate after finite step. Means in algorithm the number of steps should be clearly defined. They are finite. They are not in a infinite loop. Algorithm can produce output after some finite number of steps. Last one is the effectiveness. Every instructions must be every instruction provides some basis towards the solution. Means instruction should carry forward to the algorithm regarding the solution. So provide some base regarding the solution. Now we discuss about the efficiency of an algorithm. Efficiency of an algorithm can be determined by the order of growth of the running time of an algorithm. Here we measure the algorithm complexity of each algorithm. How? And what is the algorithm complexity? Basically it is a function which measures the time and or space used by an algorithm in terms of the input size here. Basically what data we supplied as a input for the algorithm. On the basis of that data we can determine a function. It is a function that will represent the mathematical way of representing the algorithm complexity. Here we analyze the algorithm without the execution. We cannot execute our program, only analyze the algorithm on the basis of time and space. And then what is the time complexity? Basically time complexity is the how much time, amount of time needed by an algorithm to run to completion. Means total time which will include execution time and the given final output. The total time is called as the its time complexity. Then next one is the space complexity. In space complexity, amount of space needed by an algorithm to run to completion. Here we can determine total space occupied by algorithm from variable declaration to giving final result output. Basically, in time and space complexity measurement, we can analyze there three cases. First one is the best case, second worst case, and third one is the average case. What is best case? The minimum amount of time required by an algorithm is called as the its best case, or minimum amount of space occupied by algorithm, it is its best case. Worst case, in worst case, maximum amount of time needed by an algorithm regarding space or time, it is its worst case. And average case, in average case we can determine the average amount of time needed by an algorithm or average amount of space needed by an algorithm. We can easily calculate average case by using best and worst case.